which you have collected. Now, when you look at it in the Industry 4.0 context, collecting the data, doing a comprehensive evaluation of the data, looking at the production equipment and the systems, and then trying to find out, what is it that the data is going to tell you about? What is the pattern which is going to be there around it? You could look at it from a perspective as to, whether you're going to get a good product at the end of the day or you're going to have a failure over there. You could look at whether the production equipment is going to be sustained, whether it's going to continue manufacturing or there's going to be a failure in that. If it's going to be a failure, you could actually drill down to the point as to which component is going to fail, because there will be all sensors over there. Then comes the aspect of augmented reality. Augmented reality has seen a huge adoption during the times of COVID, and this is predominantly during installation, commissioning, and servicing. When a human being couldn't travel from one city to the other, for an equipment to be installed or for an equipment to be serviced or for a plant to be serviced, most of the area was around augmented reality, uh, where they simulated the whole installation, commissioning, and they simulated the complete serviceability, and the person sitting on site could actually look at these augmented reality content created, and then they could do those activities over there. The most important aspect of additive manufacturing, which is the whole 3D printing, is just not limited to prototyping today. What we have seen is that the components which get printed on the additive manufacturing machines can be used straight away onto machineries, and they can be put straight away into use. And that is what we saw during the COVID period. There's a lot of components for equipments getting 3D printed, especially around the ventilators or for the masks, or when it came to the areas of the shields which were getting created. So a lot of use of additive manufacturing came into place. Cloud is going to be an important aspect. Knowing or unknowingly, all of us are using cloud today. A lot of the data which is on our phone and which we perceive is basically stored on a phone is actually stored on a cloud. And that's how cloud is in some way or the other getting used by us on a daily basis. A lot of information coming in from the machinery, especially connected machinery, connected devices, is being stored on the cloud, because you have two types of applications today. You have an on-premise or a physical application, and you have a cloud-based application. An on-premise application is extremely expensive and very difficult to maintain, but on a cloud, it's much more easier and much more simpler to maintain that kind of information. So you see a lot of people moving towards cloud servers, cloud storage. So that's how the whole cloud part of it is coming into our lives. Simulation plays a very important role. Now, I will be taking you through the whole digitalization process, and why simulation plays a very important role is because it allows us to create a digital twin and allows us to evaluate how a virtual setup is going to talk to a similar physical setup, and for us, in order to control and to get the physical machinery to perform much better. When we talk about horizontal vertical system integrations, we are talking about how different functions capabilities become much more comprehensive. We're talking about an upward connectivity and a downward connectivity, which we're talking about connectivity to machines, and we've been talking about data integration with networks where data can flow in. So all that is with respect to the connectivity aspects. So again, these are just words, but I will show you the actual image where you can look at how the connectivity is taking place, right from the machineries to the information moving to the clouds, and then how it gets utilized. Internet of Things, or IoT, we will be seeing, be talking about more connected devices. We will be talking about how the whole concept of product design is now moving towards a more connected device or a more connected product, or products which have a lot of sensor information going into it. So we're talking about more of mechatronics coming into picture. So earlier, devices were more of mechanical and electrical or electromechanical, but now there's a lot of sensory information also which is being put into controllers, to be putting into devices or machinery. And these sensors are basically to take readings and to send them back to your analytics, and for them to then look at what kind of information is good or bad, and then to look at those kind of look at the outcome of that information. Now, all this information is basically stored in the cloud, and that's where cybersecurity plays a large role. Now, this is to ensure that what is the intellectual property of an organization is safeguarded and it doesn't land up into the hands of people who could misuse it. So that's where cybersecurity, especially around industrial usage, is becoming much more critical today. And that is why all the cloud applications have very strong cybersecurity around it. And this is to ensure that the information which is being stored in the cloud is secure, and the myth which was there earlier that the cloud information could easily be compromised is all addressed with the cybersecurity technology. Now, when we look at Industry 4.0 across the value chain of from product design to procurement, operations, logistics, and after sales, IoT plays a role. Industry 4.0 plays a role across each area. Now, when we look at design and development is now become much more easier. The mathematical simulations, the mathematical modelings, the mathematical equations around the design aspect have become much more easier in the sense they have now been templatized. It becomes easier for somebody to go in, understand the voice of a customer, come back, put into the equations, understand how the product is going to look like, what is going to be the end effect of the product, and how is the information on the product going to be utilized. So now there's a lot, apart from a lot of CAD information, a lot of electrical wiring, routing information, there's a lot of sensor information also which is going into the design. And a lot of these components are actually getting printed, 3D printed, or through additive manufacturing. So that's the whole evolution which is happening. And all the simulation, we talk about simulation and talking about analysis, which is CAE analysis, which is going to take place. So all that is being controlled, through the cloud. So you don't have to have very high-end computing machinery with you. You can basically carry out the complete simulation on the cloud, and that's how the whole technology is moving towards it. There's a lot of AR, VR which is involved. The AR, VR is basically around the modeling of the products and the modeling of the factories. This is for you to basically have an immersive view of the product which is going to get designed, the product which is going to get manufactured, and how we're going to go about the activities of doing it. The whole procurement process is being so streamlined today that very rarely does a factory go into a stock out situation. So typically what happens in a factory is a push and a pull model. What we're talking about is based on the forecasting. You basically have a schedule given to the organization, and based on that there is a push and a pull mechanism which is followed. Typically from a Japanese parlance, it is to basically to ensure that you do a just in time, that all the products are manufactured. Now, because of this amount of automation and this amount of reordering levels and to ensure that the orders are placed on the vendors on time to ensure that the production continues, you have seen a lot of movement in the procurement cycle, where the whole procurement process has been automated, and it's not left to an individual human to do it, and that's where a lot of role of ERP comes into place. When it comes to operations, like you talk about manufacturing process optimization, equipment monitoring, so these are areas under Industry 4.0 have seen a lot of evolution happening in this particular area. Now, which could be, when we look at the manufacturing processes, how do you digitize the manufacturing processes? How do you ensure that the manufacturing process information is is the same information which is planned is going to the shop floor? How do you ensure that the same is getting executed? How do you do a closed loop between planning and execution? So that's where the whole digital twin with respect to the plant is getting created. And that is where the whole information is coming back, and you can control the whole plant to ensure that you're not missing out on areas, and you're able to control every aspect, because most of the areas in a plant would be controlled by PLCs, and you could create a digital twin, and you can use the OPC client and server which is available with all PLCs in the globe to basically have the integration between the virtual environment and the physical environment. This is to ensure that you are able to get the best out of the physical environment. The same goes into equipment monitoring. You can monitor your equipments, you can do the asset monitoring, you can do the predictive maintenance, You could look at the overall efficiency of an equipment. You could also look at the workforce safety and trainings. This is where a lot of augmented reality will start coming into picture. And then we move to the logistics area where we're looking at inbound and outbound logistics. Now, when you talk about inbound and outbound logistics, it is basically talking about in-house logistics, and you're talking about warehouse logistics. And a lot of it is actually again through automation. Now, today all of us do buy a lot of stuff from Amazon, and if you look at the logistics of Amazon, they will tell you at what point in time where is your parcel. you know so that's the amount of traceability which happens, and the same thing is being used even by the industry, because today you don't want to keep a huge stock of inventory with you. You want to have the most leanest stock of inventory, but you want to ensure that it is replenished in time. And that is where logistics plays a large role to ensure that the whole traceability of the shipment is available to you. And that's where the whole tracking of the shipment comes into picture. We were looking at the whole likes of the Ubers and Olas playing a large role in our life pre-COVID. There was a lot of fleet management which was going around that. Similarly, there's a lot of fleet management which goes around trucks in the logistics industry. Warehouse management plays a large role. We are seeing a lot of usage of ASRS today in the warehouse industry, which is automated storage and retrieval systems. We are also seeing a lot of vision-based picking and material handling, as I would call it, because robots with cameras on them are getting enabled, or robotic arms with camera on them are getting enabled. So warehouse management is not people anymore. Warehouse management is moved into the whole concept of ASRS, robotics. You know, the whole process of picking and placing is automated, and because of this, you're able to go into a high bay storage area, which otherwise with the human beings was not very much possible, because there was a limit to which you could have a forklift go into. And today, if you look at the warehouses, whether it is with respect to Amazons or whether it is respect to automotive component storage or aerospace component storage, it is all high bay racks which is come into picture. After sales is basically maintenance and diagnostics. Now, this is once a car or a product is out into the market, or let's take, for example, a small CNC machine is out into the market. Typically when we would keep manufacturing on a machine, and then we would get a lot of good products, and then suddenly we will get some lots of bad products, and that would ensure that we would go back and do a diagnostics of the machine to find out why are we getting products which are getting rejected, and a lot of rework coming into that. And then suddenly the machine would go into a failure mode, and then we would have to call somebody who would come and repair the machine for us. Now this is history, this is past. Now, as you are manufacturing, your controllers, your CNC controllers, are connected to the sensors inside the machine, and then they inform. Let's say you bought the machine from a company called Haas, and they inform the Haas engineers that this is the data which is coming out of the machine. And if any data moves into an alarming area, you would immediately get a call from the maintenance department or the after sales department of Haas, informing you that this particular machine, this is the issue which is happening, and this is the process which you would have to follow to ensure that you do not go into a failure mode, or you do not start getting bad components or components which are not cut as per dimensions which is supposed to be. So that's the whole role of Industry 4.0, right from design to after sales. Now we'll come to the whole part of IoT now. Now, with Industry 4.0, looking at IoT and the whole industrial internet, there is something called as a digital thread. When we talk about digital thread, we are basically talking about seamless flow of data across the complete value chain. Now, this is from design sourcing to testing to production, distribution, and the point of sale. Now, that's the digital thread. We are talking about product digitalization, process digitalization, and performance digitalization. Then there are digital twins which are created. Digital twins are digital models that virtually represent the physical product or process. Now, for every product, there was a design which was getting created. That is the 3D design or CAD, what we used to call earlier. But today, you're creating a design for more of a connected device or a connected machinery. That means apart from the mechanical electrical components, there's a lot of sensory information also which is going into it. And the same holds good for processes. Earlier, processes were not getting digitized, but today the whole process is getting digitized. So for every machinery, the process gets digitized, and that's where digital manufacturing plays a large role in the industry. So digital threads and digital twins are the two major aspects of digital transformation under Industry 4.0. Now let's look at the different powers of technology platforms. We're talking about 3D, we're talking about PLM, which is life cycle. We're going to talk about IoT, which is orchestration, and we're going to talk about experience, which is complete augmented reality. Now, when we talk about 3D, we're talking about creating designs which are more associative in nature, which are more generative design, which is a more 3D digital twin with IoT connectivity. We're talking about a product which can talk to a physical product, a digital product which can talk to a physical product. No longer are the instructions going to be paper-based. The instructions are all moving into a 3D environment. We are talking about design for additive manufacturing. We're talking about multi-CAD collaboration. So, there are a lot of players in the CAD industry, the likes of Creo, NX, CATIA, the whole AutoCAD aspects coming into picture. Now, these talk to each other today. If you go to any industry, no industry uses one single CAD platform. An industry uses a multiple set of CAD platforms. And we're talking about real-time simulation. When I say real-time simulation, I'm talking about a CAD drawing which has been created, or a CAD model which has been created, which is going to be simulating the physical behavior of the same component. And this is basically done through a PLC integration using OPC client and server. So that's the whole change which is happening on the 3D design aspect. Now, when we come to the PLM aspect, PLM is available on the cloud. The PLM as a solution is available on the cloud. It all starts with the requirement management, goes into content management, collaboration, workflow, BOM management. So, 3D gives you the complete engineering bill of material which is coming in. What is managed on PLM is the manufacturing bill of material, the bill of processes, the procurement bill of material. All that is the different BOMs which get managed over there. What also gets managed in your PLM is change configuration, and the whole digital thread around the processes. The whole digital manufacturing is encompassed under PLM. Then we're looking at product variability, we're looking at the service management and the quality management. Quality is one area where a lot of emphasis is being given today, because the buyers have become more sensitive towards quality. People are looking at performance, and performance is an outcome of quality. That's where quality management becomes the key today. And the whole manufacturing process management, where we're looking at an integration with EBOM, MBOM, in which factory, on which line, on which machine is it going to get manufactured. So that's the drill down which is happening in the manufacturing process management area, and that's the whole PLM area for you. Now we have the EBOM, we have the MBOM, we have the complete digitalization of the product and the process. Then comes the whole aspect of IoT. Now under IoT, what happens is we know where the sensors on the product are. We know where the sensors on the machinery are on the actual physical shop floor. So that information starts getting gathered. Now, when you start gathering that information, you have a lot of information with you, a lot of information. And that is where data analytics or data sciences start playing a large role. And that's become an area of specialization today. And with that, you start finding out the trends, or you start finding out, for what values do you get a good product or a bad product? For what values is the system in the best of its health? And in what values is the system going to go down on its health or towards a failure? So that's the whole data sciences or the data analytics which starts getting done. Then comes in, what do you do with that information? That information needs to go back to the user so that he knows how to utilize that information. And that is where you start creating applications. Now, there is a lot of applications which get created. Now, once you create an app, the application also needs to be hosted. So you need to know whether you want to create a cloud-based model, or you want to create a SaaS-based model. So all that starts coming into picture, and that's where the whole application comes in. And then that moves into artificial intelligence, machine learning, and deep learning. So those are the outcomes of IoT. Now, coming to the aspect of you have done the IoT, you want to understand the whole experience around it, is where we're talking about areas like, virtual reality, augmented reality, mixed reality. So that's where the whole experience authoring comes into picture, creating that whole area. And that encompasses from design to PLM to IoT and serviceability. So that's the whole area which gets captured. Sorry. If you look at an IoT platform, let's look at an overall view of an IoT platform. So over here, you have machines, you have factories, you have CAD information, PLM information. If you're going to be talking about, the construction, and you have architectural engineering and construction information, the whole BIM information where you're talking about smart connected buildings. And what is of essence over here is to look at the 5 pillars which are there. Sourcing the information, to contextualize the information, to do the synthesis of the information, to orchestrate it, and to engage with that information. What do we mean by this? When I say sourcing the information, which I've been talking about, is basically to get the information from the shop floor. So that is where we put in sensors, connect them with PLCs and IoT gateways, and we take the information out of the shop floor. Now, you could use existing product clouds, or you could have separate clouds for IoT altogether, but that's something which is left to an organization. And then is also to connect them with other business systems like CRM, or that is customer relationship, and ERP solution, which is enterprise solutions. And this is to ensure that, IoT is across the complete domain of an industry. And all information is being taken from everywhere where it is required, because it becomes very important for you to have the right set of information with you. And that is why sourcing is very, very critical. Now, once you have the information or the data, you have to contextualize the data. You have to structure the data so that it starts making sense to the people who are looking at it. Otherwise, there is so much of data that you would actually get lost. You would not know what's happening. You need to organize the data of the physical systems of the products in such a way that you're able to say what is going to be the outcome of this data. And then comes the whole aspect of synthesis, where you do analysis, simulations, you look at the predictive behaviors. So, and that is where the performance of the whole machinery or a product starts coming into picture. Then comes the aspect that you need to orchestrate. You need to drive actions. That's where, for example, you need to ensure that the physical system in a factory is not slowing down the complete factory line, or the closing of a valve. So all that is the actions which need to be taken. Now, for example, if a machinery is going into a failure mode fast, and the person who is operating that machine is ignoring all the signs being given to him, that is where decisions have to be taken to be that the system needs to be closed down immediately. And that's where you need to engage. And when you talk about engagement, we're talking about creating applications which will take the decisions, or which will enable you to take a decision. So these are 5 areas: sourcing the information, contextualizing the information or structuring the data, synthesizing the information, which is basically doing analysis or simulations or prediction models around it. Orchestrating is basically to understand what action needs to be taken, and engage is for that action to be taken. So this is how an IoT platform typically works. Now, if I take it back to the whole product development process, I'm taking you through a complete end-to-end process now. I'm talking about, from here, I'm going to talk about, when somebody conceptualizes an idea, till the time that information goes into, the product gets manufactured and goes into serviceability. So this is the whole life cycle which is followed. So, we spoke about connected products, we spoke about connected machineries, connected plants, and how IoT is playing a huge role around over there. So this gets into the aspects of different areas. Now in design, what happens? In design and engineering, what happens? It starts with conceptualization of a design, getting into a detailed design, doing a simulation, and then creating a prototype or manufacturing using additive manufacturing. Now, when you conceptualize a design, you do a lot of engineering calculations. So if you go back and see, when we spoke about the platforms, we spoke about 3D as one of the platform areas. That's where you're doing a lot of conceptualization, doing a lot of engineering calculations, ensuring that this is as per the requirement of the customer. When you're doing the detailed design, you're ensuring that you're creating the 3D models, you're doing a DFA, DFM, design for assemblability, design for manufacturability is carried out. You're doing design with sensors, you're putting in augmented reality design reviews. Simulation is more on behavioral design, structural dynamic designs, and then the whole prototyping, additive manufacturing, and the whole digital twin of the product getting created. Now, when that information flows into manufacturing, you're doing the whole tooling designs, the machining designs, the manufacturing bill of material, the processes which is going to be followed, the augmented reality of the whole work instructions, connectivity of the machinery using industrial automation, looking at the quality gateways and what quality checks have to be done. And from manufacturing, moving into serviceability and maintenance, where we're looking at plant maintenance, we're looking at asset management and predictive maintenance. We're looking at the whole service design. Now, if you look at the whole services industry, the whole service design, where we're talking about digitalization of the service information, we're talking about the procedures to be followed, where we're talking about the service bill of material or the part information from serviceability perspective, and the complete augmented reality authoring of the service manual. So that's something which is done around the service design. And then comes the remote monitoring of machinery, remote monitoring of plants from a serviceability, or remote monitoring of a product. Now, if you look at your cars today, the cars are basically where it could be remotely monitored by the OEM which is manufacturing the car. Come down drastically, because if they realize that the person who has got into the car is not the actual owner of the car will not start. So that's one area which becomes very, very critical. And then IoT plays a large role with the cybersecurity aspect coming into place. Now, we look at the connected landscape perspective, from the voice of the customer to the design, to the PLM, to the prototyping and validation, and the production connectivity to ERP. The top layer is basically where things remained the same from how they were being carried out earlier, just that there is a lot of traction now coming in with respect to augmented reality, additive manufacturing, design with sensors, all that coming into the area. Now, when that gets connected to an IoT platform, a lot of information starts flowing in from PLM to IoT. That's where the whole digital twin aspect comes into place. And then the IoT platform connects to the machineries on the shop floor. And that is where we're looking at asset management, controls, OE coming into picture. And all this is talking to the physical system of the end product, which is getting manufactured, which could be an aeroplane or a drone, or it could be a car, or it could be a ship. And there is a huge role of augmented reality, which is taking place in terms of manufacturing and serviceability. If you look at industrial IoT, manufacturing use cases, there are many. I have just listed down a few over here. If you look at the manufacturing engineering area, we're looking at the bill of material or the BOM transformation. We're looking at the whole digitization of the process planning taking place, the digitization of the factory design, the digitalization of the work instructions, which is complete augmented reality authoring, which is taking place. So that's one huge area where people are specializing, especially with industrial IoT. The other area is production execution. Today, before a person goes in to produce a new, when we talk about NPI or a new product introduction, before the new product is actually manufactured, the complete digital assembly of that is done. So a viability study or a feasibility study with a DFA or a DFM is already carried out. And that is where the whole digital assembly and machine instructions play a large role with virtual reality and augmented reality. Now, there are a lot of HMIs, human machine interfaces, which is nothing but operator screens, which has been unified in a lot of industries, which allows the person to see what operation he needs to carry out, which component he needs to pick, from which particular bin he needs to pick it up. And this is all connected back to the stores. So when he consumes the component, automatically the store depletes. And when he is about to hit the reorder level, the store goes ahead and automatically places the order on on the vendor or the supplier who's going to supposed to supply that components, and thus completing the logistics chain also. So that is where order management takes place. uh, the genealogy and the digital twin of the actual machinery is also created over here. The labor tracking, shift management, and paperless operations are other areas of production execution. Now, when we come into the area of supply chain and logistics, we're looking at how operations can be carried out remotely. That is why we're talking about robots with visions, and we're talking about ASRS systems. We're looking at the visibility from the supplier end to ensure that your supplier is able to supply the component on time. Otherwise, you would go into a stock out situation and production would stop. If a supplier A is not able to supply, can your supplier B double up? So that's the kind of strategies which go into supply chain and logistics. AGVs are getting utilized as a part of this. So there are times when you would see that an AGV picks up the components from a store, and then he goes to the line side, dropping the components and coming back. So it's like a train. He goes around, finishes his operation, and comes back. And that's where a lot of AGVs are getting used. And RFIDs are being used to track materials, tools, optimizations of tools, utilization of tools, inventory storages. So all this comes under the supply chain area, and all this is controlled by industrial IoT. Maintenance and serviceability is another huge area where you can where you're looking at the predictive and prospective analysis being carried out, digitalization of repair and service instruction manuals using augmented reality, real-time alerts and fault identifications. Again, this is due to connected machineries which you get to know. Asset handling, asset tracking is something which all will be done under maintenance and serviceability using the IIoT platform. Environment, health, and safety. A lot of emphasis is being given to this today, and I'm sure after the COVID pandemic, you would find that this is going to be much more stringent as we move forward. The whole area over here is, hello. The whole area out here is to monitor operations and the conditions under which the operations are being carried out. Uh, it's also to train the people on the health and safety procedures for them to work under. This is to ensure that no accidents happen. The whole energy management system is going to be looked at from an environmental health and safety perspective. Quality and test is another area where industrial IoT plays a role, and operations management. All of this is then connected with automation, and information is then flowing in. And the bottom layer you can see is connected through IoT gateways for connectivity, bidirectional integrations with ERP, manufacturing execution systems, and other enterprise systems, OPC server monitoring, and machine-to-machine tagging. So that's how the whole industrial IoT manufacturing use cases are done. Let's take the example of CNC technology. I've just taken an example of two machines over here. One is a lathe, and another is a 3-axis VMC. And when we connect the CNC machines with sensors, wired or wireless, that information flows into a IoT gateway or router, and from there onto to the cloud for data processing, storage, and for industrial IoT applications. Now, this is a smart machine. We're talking about a smart machine over here. And, over here, we're talking about sensors, software for networking, cloud computing, and analytics. And the 5 basic functions which we have to look at from, the IoT platform for CNC machines connectivity is sensors, data collection, edge computing or data analytics, cloud data processing and storage, and IoT applications. Now, what are the type of sensors which we can put in? I'll just give you an example with respect to the sensors which can go into a CNC machine. Is sensors for temperature, pressure, and vibration. Now, these sensors go onto every axis of the machine. So if you're talking about a 3-axis machine, All these three sensors go onto the three axis, and that is how the information is collected from there. Today, there are dampeners on top of which the CNC machines are. We don't grout the machines today. We put them on top of dampeners. There are very few vibrations, but when vibration increases in a machine, that is definitely something wrong with the machine. And that's the kind of IoT applications which is done, is to ensure that the machine uptime is maintained, the productivity is maintained, the quality is maintained. So applications are created around that. Another big area is robotics. Robots are being used across the industry, right from manufacturing to stores to supply chain. So a lot of robot utilization happens. In the robot industry, if you look at the domains, you have material handling, packing, cutting, welding, painting. So all that is there. And they're all connected with the DCS. DCS is a PLM system. Sorry, it's a PLC system. So it's a distributed control system. It's a high-end PLC which is used. And then you have the complete robot controller system. So the robot has its own controller. So a KUKA robot has its own controller, ABB robot has its own controller, Fanuc robot has its own controller. So all different manufacturers have their own controllers. So what does the robot controller do? It basically allows you to operate the drives and motors of a robot. You can teach it using a teach pendant, or you could also teach a robot using digital manufacturing, is what we call as offline programming of robots. And that communication typically takes place through a PLC to the kind of application the robot is supposed to carry out. So there are different robots for different applications. And when this robot is connected through sensors to a gateway, there's a lot of information which flows into the IoT platform, and you're looking at productivity improvement, you're looking at the overall efficiency, you're doing predictive maintenance, and all that information from the IoT platform, which is a cloud-based or an on-premise, is then also shared with multiple, other applications such as ERP, SCADA, manufacturing execution systems, and a lot of applications are created around it. A lot of IoT applications are created around it. So this is the whole connectivity framework which takes place for industrial robots. When we look at the additive manufacturing technology in today's era is not limited to only creating components for machineries. It has gone much beyond that. So, it is being used for renewable energy, whether it is wind or solar, it is used for both. It is also being used by students for doing a lot of architectural design and printing of that. It is also being used by the students of history in terms of fossil design and fossil printing. It is also being used by students of food technology in terms of, how can they use additive manufacturing for 3D printing of food, so that there are already machines which are out, but in the future there would be many more machines wherein you go and choose from the menu, and actually your food will be cooked right there in front of you from the machine and served to you. Then there is the whole machinery aspect which comes into picture, where you have students from the engineering domain. Then you have students from the area of geography who want to look at the complete topology of an area, the demography of an area, and 3D print that. Then there are people who would be using it around chemistry to look at the complex molecular chain and to 3D print the complex molecular chain. Then you have the medical students who would be using this in terms of creating cross sections or creating components which are going to be used in the human body. So we are seeing a lot of use of additive manufacturing in the area of composites, especially for artificial limbs, where it comes into picture. So that's one area where additive manufacturing is becoming a technology of tomorrow across all domains. So it's not just limited to engineering. So it's across all domains. And if you want to have sensors placed onto this, the whole design is done in such a way, and it's also printed in such a way that sensors can seamlessly be integrated into this, and the whole IoT aspect can be easily carried out. I'm moving away into a slightly different areas, healthcare. We have all seen that how badly we have got affected by the COVID. Even today, the numbers are on the rise. We all are, I would say we are not scared, but we are more informed in terms of the precautions which we need to take. This seminar would have been done in person if not for COVID, where it's being done on a virtual environment. But again, the whole healthcare IoT perspective is for a person to do, to utilize things like airflow sensors, ECG sensors, spirometers, glucometers, pulse oximeter, and all this information going into a gateway, and that information going to a doctor who can do a remote diagnostics and tell you as to what's right or what's wrong with your body and what precautions you need to take. So this is one area which is a huge growing area, because it's not possible for a doctor to attend to thousands of patients a day. But when he is able to get such information remotely from from a patient who's used to utilizing the healthcare IoT system, he would be able to do the diagnostics much faster and cater to solving much more issues for a larger number of patients. So that's where the whole healthcare IoT is playing a large role. Agriculture IoT is one area which is growing extremely fast today, extremely fast. So there are two aspects to the whole agriculture IoT area. The whole aspect over here is, we're talking about the IoT platform, cell phone application, irrigation system, weather systems, connecting it to satellite images, and the whole sensors and the gateway. If you look at this over here, I'm just depicting a farm, and the farm has a lot of sensors connected to a gateway. And those sensors are for soil temperature, soil moisture, what is the ambient temperature, humidity, lux, what is the wetness of the leaf, and the weather prediction which comes in. So these sensors are placed on the farm, and through a gateway, all the information is going onto a cloud server. Similarly, there are a lot of control gateways. So you have a lot of other machinery on the farm, which is the controls for irrigation, nutrients, logs for water quantity, nutrient quantity, voltage variation, alerts over voltage, high voltage, low voltage, dry runs. So all that information also is going onto the cloud. There's a lot of information which is coming in from the satellite, and that is basically being used to forecast rain, temperature, wind, plant health and moisture, soil moisture. So all that information also comes in from a satellite, and all this information is pushed into an IoT platform. Now, once this information is pushed into an IoT platform, there's you have the whole set of teams sitting over there looking at this data and doing a lot of analytics and analysis on top of this as to is there too much of water on the farm? Do we have to control the water flow to the farm? Is there an issue of crop getting damaged? Pesticides need to be sprayed. Nutrients have to be put in. How much nutrients have to go in? The whole aspect is to improve the yield of the farm. How is it that you can improve the yield of the farm? And I can take it a step forward and connect it with drones. Now, drones could have cameras. Drones could have, if my farm is really large, my drones could go and do a survey, which could have sensors on top of that. As it's flying, it's recording information. So drones is another area which could come into picture. And we're looking at over here is the whole wired systems, where we're looking at water level sensors that's for a pond or from wherever the water is being pumped in. We're looking at the voltage and the current monitoring system. We are looking at the flow meters. We're looking at sand filters. We're looking at connectivity to pumps. So all that is coming into picture, and the whole weather monitoring system. So, a smart farm consists of all this. Now, what are the industries related to agriculture IoT? You have farming companies, you have seed production companies, you have agri input companies, you have companies which are lending for farming, there are crop insurance providers, and there is government and advisory. Now, a farmer is basically producing for consumption, and the consumption is just not by us, the normal citizens of the country, but the consumption is also by a lot of companies. And that is where we see that a lot of people, a lot of companies buy directly from the farmer and package it and sell it out into the market. Now, these people are monitoring the quality of the yield which is coming out, the quality of the produce which is coming out. And that is why it becomes extremely important to basically do the crop stage management, remote monitoring, yield health advisories, and the micro and macro optimization of the whole farming process. We're looking at smart cities. When we look at smart cities, a smart city consists of different areas like manufacturing, mining, power generation, communication, constructions, buildings, campuses, rails, suburban rails, environmentals, roads, bridges, water and wastewater management, and asset management. So huge offering from a smart city perspective. Digital twins of smart city is what is getting created today, and a lot of IoT is being utilized in that. Now, how is it that it's being done? Giving you an example with respect to pollution levels. Now, sensors are being used in every city to look at what are the different pollution levels, and that allows you to take a decision in terms of how to control the pollution levels in a smart city. Similarly, the switching on and switching off of the lights is based on the lux intensity of the sun. And if the lux falls to a certain level, the street lights automatically switch on. If the lux reaches to a certain level, they basically switch off. Even from a parking perspective, there are apps which are getting created based on the information of which parking lot has how many parking slots available, so that when you are traveling inside a smart city and you want to park in a particular area, it basically tells you that, this particular area here you have so many parkings available. So it's becoming more smarter in that way, so that you don't have to go around in circles searching for a parking. Similarly, when it comes to the water and wastewater management systems, there's a lot of IoT which is going into it in terms of the water consumption, in terms of the sewage, in terms of the whole sewage treatment plant which are being put in, or the water treatment plants which are being put in. So all this is being controlled from an IoT perspective. With this, I come to the end of my presentation, and in case of any questions, I'll be more than happy to answer it. I think I'm just in time. I've come to around 6 o'clock now, and we have half an hour for question and answers. So I would stop sharing and I would come on the screen. If there are any questions, I would be more than happy to answer them.
Thank you very much, sir, for your nice presentation and sharing knowledge about this industrial Internet of Things. So, sir, we can here see one question came in section questionnaire, question and answer tab. So, the person who is asking is Venkata Ajay Kumar ji. He is asking about, can you explain how the blockchain is helpful in logistics? How about the research aspect of blockchain into manufacturing?
See, blockchain is playing a large role today, but even from the terms of doing the blockchain aspects, if you look at India today, in India, even to get into the blockchain aspects of logistics or manufacturing, you have to ensure that you are getting your whole automation aspect correct. Research is taking place, but the adoption is the most important aspect. And that is where we feel the industry and academia have to work together, because till the time academia doesn't do a research which is meaningful to an industry, the adoption doesn't become very meaningful. Today the industry is struggling with the automation process itself. So blockchain is pretty far off. So I'd say, whatever we talk about blockchain today is going to be very theoretical. Very few companies would have actually adopted it. In the long run, yes, it's going to be a very, very key factor, which is going to be a part of the growth of the industry 4.0. But that is where we see research coming in from academia, which would be much more meaningful for the logistics or the manufacturing industry to adopt it. But as of now, I would say the focus has to be given on automation and industry 4.0 adoption before we move into the blockchain aspect.
So now regarding questions, we have no more questions in question and answer tab. So it's time for the vote of thanks, and our director, sir, Professor P.P. Chattopadhyay, is here. So he would like to address something, or he would like to ask something.
Good evening. I'll start with a question on my part. I mean, here we are. Huh? we are moving towards the new era of manufacturing encompassing automation, IIoT, artificial intelligence, everything. But we already have a manufacturing base which are operating over the years.
Right.
Now, in terms of competitiveness and to capture the market in the emerging scenario, I mean, we cannot just bypass the existing manufacturing infrastructure which is already there, and we cannot wait for the modern infrastructure to come up and to develop with the modern technology. So where is the how is the opportunity to go for a backward forward linkage so that we can support them.
Hello, sir. Hello. Hello. Hello.
Am I audible?
Yes.
Sir, I had lost you around when you were saying how can we support the industry?
Yeah. Am I audible now?
Yes, sir, you are.
Yeah. Uh, I mean, there must be some framework which can help the existing manufacturing infrastructure to catch up with the modern framework of Industry 4.0. I mean, they cannot be left out. And I don't think it is feasible for a country like India to create a new infrastructure equipped with Industry 4.0 to get into the market. Similarly,
Absolutely, sir.
yeah, we have.
Can I answer that part and go to the next question after that, sir?
Yeah, sure.
Otherwise, what will happen is I'll miss out on answering one part of your question.
Yeah, sure.
So, sir, I totally agree with you. If you look at the MSME, which is currently catering to 40% of the GDP of the country, most of them are using conventional machinery. They're not using smart machinery. And a lot of problem which they are facing with that machinery is the quality of the product which is getting manufactured. And because the entrepreneur or the owner of that organization is so involved in the day-to-day manufacturing that when he wants to go out and venture into a new business or grow his business, he is not able to do so because he doesn't know what is happening behind his back on the shop floor. So he's scared that there would be a drop in production, there would be a compromise on quality which will take place. The workers may not work to the same efficiency as they were doing when he's sitting in the shop floor. So, when we work with the MSME, what we tell them is even if you have conventional machines, the conventional machines can be retrofitted with sensors and controllers. This is a huge market in our country today because as an MSME, as an SME, small medium enterprise, he does not have the bandwidth or the financial muscle power to go and invest into a modern machinery. But what he's saying is if I am able to monitor my machines remotely by doing retrofitment of sensors and controllers, I can go and source more business. And as I grow, I can start investing into smart connected machines. So that's one area where today a lot of system integrators or a lot of system integration houses are working on converting conventional machines into smart machines. But the period for which it will operate is limited to around 4 years or 5 years, after which you would have to go for a smart machinery. So he's getting a lead time of around 5 years to work with retrofitted smart machines and then go and buy an actual smart machinery. So this is already happening in the country and it's happening at a very fast pace.
Yeah, that is quite encouraging that we can uh, adapt this advancing trend of manufacturing in inclusive manner so that none of the potential is left out. And on behalf of NEEP, I would like to convey my heartiest thanks to you for presenting a very enlightening lecture. I mean, it will provide an overview of Internet of Things, what we talk about frequently, but we are not we don't dare to get into it from other domains. There is a trend among us in academia and in knowledge sector that we are comfortable within our silos. So to adopt this integrated framework, we need to have courage, enough courage to get out of our silos and to adapt whatever is happening around. So definitely your lecture will be motivating for us in that direction. Thank you, Mr. Fegel.
Sure, sir.
Thank you very much for being with us.
Thank you, sir.
To be with us. Thank you.
Thank you, sir. Thank you very much. And in case if I missed out any questions, you could definitely email it to me and I would be more than happy to answer them, sir.
Definitely we will share.
Thank you very much, sir. A very good evening to everyone and please stay safe and stay healthy.
So, announce for the news domain. Yeah.
So this is an announcement for the attendees. So tomorrow we have sessions that is going to be started from 10:30 on topic metal forming mass production to mass customization, given by Professor N.V. Reddy from IIT Hyderabad. That will start from 3 o'clock. Sorry. So next session that will be going to be start again 5 o'clock in the evening. The topic will be laser in advanced manufacturing. The talk will be given by Professor Indranil Manna from IIT Kharagpur. Okay, with this, I would like to end the online meeting for this short-term course. ऐसा पेपर देंगे तो क्या होगा?